So this first video, we're going to learn about translations. But first, let me summarize what the unit's going to be about. This first unit is about transformations, particularly transformations in the plane. And all that transformations are is they are rules for moving points and moving shapes around in the plane, as I'm writing here. They're rules for moving shapes and points around in the plane. And there are different sorts of rules, and we're going to learn about 4 different rules for moving shapes around the plane. So like, for example, if this Q here is a shape in the plane, we could slide it like that without turning it. That's called a translation. We could rotate it like that, and that's called a rotation. Or we could reflect it. And the way we could physically reflect a Q is by turning it upside down and laying it someplace else. Those are our 3 what are called rigid transformations we're going to learn about. So, the first transformation that we're going to study this unit is the simplest one. It's called a translation. The translation is when all the points in the plane move the same distance and they move the same direction. They go the same direction, everything's going to go the same direction, and everything's going to go the same distance. So the effect of this, when you do this, is that all the points in the plane, or the shape that you're going to move, it slides without turning. So for example, if I have this Q here, a translation would take it and slide it without turning it to someplace else. And it might go, it won't turn like that. It's just going to slide without turning in one direction. And every point on that Q was going the same direction, and every point on the Q was going the same distance. So there are a few different ways to define our translations. One definition is called using a vector, a translation vector, to define the translation. Remember that in order to define a translation, we need to specify a distance and direction. So let's say we're going to translate this triangle. So one way to define a translation is by drawing an arrow like this. And this arrow is telling us how we're going to translate this triangle. So the question might say, translate this triangle by this vector that I've drawn here. So remember that a translation needs a direction and a distance. So the direction is clearly which way this arrow points. We're going to translate that direction. But the length of the arrow from beginning to end shows you the distance. So that's how this vector shows us distance and direction. So if I get out a ruler here, I can actually measure how long this is. If I lay this down here, it's about 27 millimeters, 2.7 centimeters. So that means each point of the triangle is going to move 2.7 centimeters. So I'm going to start with the first corner of the triangle, and I'm going to go 2.7 centimeters. Notice they're all moving in that same direction, up and to the right the same way. Then I'm going to have this corner of the triangle, that vertex, go 2.7 centimeters. Then finally I'm going to have the third corner of the triangle go 2.7 centimeters. And knowing where those 3 points go is enough to tell me what happens to the triangle. So if I call this point A, the thing that's usually done when you're translating is you put a little tick mark to show the image point. So I have A and A prime, and then I'm going to have B. You read that tick mark with a little prime, B prime. We have C, and over here will be C prime. So the image of A is A prime, the image of B is B prime, the image of C is C prime, and then I connect those in the same order. and I get the image triangle. So I start with triangle ABC, and I have my image triangle A prime, B prime, C prime. Like that. So that's one way to define a translation, is by drawing a little arrow that's a vector. It gives direction and distance. The second definition, or the second way, I guess, to define what a translation does, remember we need to define direction and we need to know distance. So one very straightforward way of defining it is simply describing direction and distance in words. Rather than by drawing an arrow to give direction and distance, we write out a little sentence to describe direction and distance. So describing direction and distance in words. Now direction or distance is straightforward. You say 3 centimeters, 4 centimeters, whatever. But direction presents a problem, because how do we describe a direction? There are different ways. You could use north, south, east, west, or different things. And so one thing that we will be doing a lot is we will describe directions using degrees. Okay, 0 degrees will be off to the right. And as we go counterclockwise around, we get other directions. So 90 degrees will be up, 180 degrees will be to the left, 270 degrees will be down, and then going all the way back around 360 degrees again will be back to the right. And we could do in between measurements if we wanted to. We could do 45 degrees, which would be halfway between 0 and 90. But let's look at an example. So here I have a triangle, and I'm going to translate this triangle. And let's say that this bottom edge of the triangle is 6 units long. It doesn't specify inches, or we won't specify inches or centimeters, we'll just say units. So, and let's say we want to translate this triangle 3 units in the 180 degree direction. So that specifies distance and direction. And that's what we need to specify. The 3 units means we want to go 3 units. But what does 3 units mean? Well, the triangle tells us what 6 units is, so this must be 3 units right there. Half of the 6. In the 180 degree direction, that's a fancy way of saying I want to go to the left. 180 degrees is to the left. That means I'm going to take each point, I'm going to label the vertices A, B, and C. I want to move each of those vertices 3 units in the 180 degree direction. So there we'll move the first. Here's the second point. Each point's moving to the left. Notice C prime ends up being on the triangle again. That's fine. There's nothing wrong with that. So we connect the dot. And there's the image triangle A prime, B prime, C prime. There's original. It's moved over 3 units to the left, and there's the image triangle.